Very good morning, students. Welcome to science session for class 10. And today we are going to see unit 10, types of chemical reaction. Now in this lesson we will be learning about what is chemical reaction, what is unbalanced chemical reaction, the types of chemical reactions. Now here we have the classification based on the nature of rearrangement of atoms and the classification based on the direction of the reaction. And we will be learning about the rate of chemical. A very good morning, students. Welcome to science session for class 10, and today we are going to see unit 10, types of chemical reaction. Now in this lesson we'll be learning about what is chemical reaction, what is unbalanced chemical reaction, the types of chemical reactions. Now here you have the classification based on the nature of rearrangement of atoms and the classification based on the direction of the reaction. And we'll be learning about the rate of chemical reaction, factors influencing the rate of chemical reaction, state of equilibrium, ionic product of water, pH scale, and the role of pH in everyday life. And we will also deal with the problems based on pH, and these problems are very important. Let's go into the session, children. Now children, chemistry is all about chemical reaction, isn't it, children? We come across many chemical reactions in our day-to-day life, isn't it? Now we need energy for the various physical activities, isn't it? Now where do this energy come from? Digestion of food. Digestion of food again is a chemical reaction. Photosynthesis, again it is a chemical reaction, isn't it? Combustion of fluid, oxidation of the iron, that is nothing but the rusting of iron takes place, isn't it? Now the burning of the petrol, isn't it? So all these are chemical reactions. So we come across various, many, n number of the chemical reactions in our day-to-day life. So all these chemical process are nothing but the chemical changes of the material takes place. So the material which undergo changes are converted into another material, isn't it? So that we call it as a chemical reaction, isn't it? So in this chapter we'll be learning about what is chemical reaction, now how is a chemical reaction represented, and what are its types. Now let's see what is a chemical reaction. Now, a chemical reaction involves the breaking of old chemical bonds and formation of new chemical bonds, isn't it? Now, whenever a chemical reaction takes place, the old chemical bonds get broken and the formation of the new chemical bond takes place and the product is obtained, isn't it? So, what happens in a chemical reaction actually? In a chemical reaction, the atoms of the reacting molecules or the elements get rearranged. Why they are rearranged? Because the formation of the new molecule or the compound takes place, isn't it? So this is the first step, that is the atoms of the reacting molecules or the elements get rearranged so that a new molecule or the compound is formed. The next one is the breaking of the old chemical bonds takes place and the formation of a new bond takes place, isn't it? Energy is observed when there is a breakage in the chemical bond. Now energy is released when the bond formation takes place. So bond breaking observes energy, whereas the bond formation releases energy. So these are the three steps that takes place in a chemical reaction. That is, first the rearrangement of the molecules takes place so that a new molecule is formed. Now for that, breaking of the old chemical bond and the formation of the new bond takes place. Now when a bond is broken, right, when a bond breaking takes place, the energy is observed, and when there is a bond formation, the energy is released. Now let's see an example. Now for example, methane reacts with oxygen and it gives carbon dioxide and water. So this is the chemical reaction, isn't it? Now in chemical reaction, now what happens? The reactants combine together and a new product is formed. Now here there is an breaking of the bond between the carbon and hydrogen, and a new bond is formed between the carbon and oxygen, so that the carbon dioxide and water is formed. Now these two are the reactants. So these are called as the reacting molecules, and the compound that is formed is called as the products. That is, carbon dioxide and water are the products, and methane and oxygen are the reactants. Now, how are the chemical reactions represented, right? Now, there are few steps that has to be followed to write the chemical reaction. Now, chemical reactions are represented using chemical formulas, right? So, using the chemical formulas, we use the chemical formulas to represent the chemical reactions. Now, how is the chemical reactions written? The reacting molecules are written on the left hand side, and the products are written on the right hand side. Now this arrow marks that divides the reactants and the products, that is, you put an arrow mark in between the reaction, isn't it? So this indicates the direction of the reaction. So the arrow mark indicates the direction of the reaction. Now in a chemical reaction, the number of atoms of the reactants, that is the number of atoms that is present in the reacting molecules, should be equal to the number of the atoms in the product. By law of conservation of masses, the number of atoms of the reactant should be equal to the number of atoms of the product. Now, in the chemical reaction, the physical state and the condition of the reaction should also be mentioned. So, the chemical reaction should be represented in terms of formula. The reactant should be written on the left hand side and the product on the right hand side. The arrow mark indicates the direction of the reaction, and the balancing of the reaction is a very important one, that is, number of the atoms of the reactant should be equal to the number of atoms of the product, and the physical state and the condition of the reaction should also be mentioned in the reaction. Now let's see an example, children. Here we take the example of methane combining with oxygen to form carbon dioxide and water. Now methane and oxygen are the reactants, and these are written on the left hand side. Now this is the product that is formed, that is, carbon dioxide and water are the products formed. So these products are written on the right hand side. Now in between the reactants and the products you have the arrow mark, isn't it? So this arrow marks indicates the direction of the reaction, that it takes place in the forward direction, right? Now here I have written something in bracket, isn't it? Now this methane is in the gaseous form, and oxygen in the gaseous form, carbon dioxide in gaseous form, and water is also present in the gaseous form. So this represents the physical state of the reactants and the products. Now, how is the physical state represented? Now S is used to indicate the solid state, L for the liquid state, G for gaseous state, and AQ for the aqueous solution. Now these are the symbols that is used to represent the phase or the physical state of a reaction. Now we said about the condition, isn't it? Condition of the reaction and the physical state of the reaction should be mentioned. So this is about the physical state or the phase of the reacting molecules or the product, isn't it? Now look into this example, children. Here you can see an example of silver bromide decomposes to give silver plus bromine, right? Now this reaction takes place in presence of the sunlight, right? So this is the condition under which the reaction takes place, right? Now here silver bromide is in solid state. So the physical state of the reacting molecule is in solid state, and the metallic silver is in the solid state, and the bromine is in the gaseous state. So this physical state of the reaction should be mentioned, and the condition under which the reaction takes place should also be mentioned in a chemical reaction. And here the condition is the presence of sunlight. Next we said that according to law of conservation of masses, we said that the balanced reaction should be written, right? So the reaction, the chemical reaction is incomplete without a balancing, right? So balancing of the reaction is must, isn't it? Now for example, take this example, methane combining with oxygen to form carbon dioxide and water. Now let's see the number of atoms that is present on the left hand side and right hand side, that is between the reactants and the products. Now here on your left hand side, how many carbons are there? Only one carbon. Now how many hydrogen? 4 hydrogens are there, and oxygen is 2. We are considering the atoms, right? Now on the left hand side, how many carbon? 1 carbon, hydrogen, 2 hydrogen, and 3 oxygen. Here you have 2 plus 1, so 3 oxygens are present. Now the carbon on the either side is the same, but hydrogen, here it is 4 and on your right hand side it is 2, and similarly oxygen on the left hand side it is 2, on the right hand side it is 3. So it has to be balanced, right? So first we'll start balancing the hydrogen atoms on either side. Now look into this reaction, children. Here how many hydrogens are there? On your right hand side there are 2 hydrogen, on your left hand side it is 4. So I'll put 2 in front of the water molecule. So here you have 2 into 2, this should be multiplied. So here it is 2 into 2, 4. So here on your right hand side now you have 4 atoms. Now here on the left hand side also you have 4. So the number of hydrogen on both the sides, that is on your left hand side and right hand side, is equal. Now we have to go into the oxygen atom. Now how many oxygen? There are 2 oxygen here. Now count the number of oxygen on your right hand side. Here you have 2, and this 2 is common to the hydrogen as well as the oxygen. So here you have 2 oxygen atoms. So 2 plus 2, 4 oxygen atoms you have on your right hand side. So this should be balanced, isn't it? So I'll put 2 here. So this will become 2 into 2, 4. So now you have 4 oxygens on your right hand side and 4 oxygen on your left hand side. Now this reaction is in balanced reaction. Now you count the number of carbon. Here you have 1, on your right hand side you have 1. And how many hydrogen on your left hand side? Here this is 4, and here 2 into 2, 4. Now considering the oxygen, here 2 into 2, 4, and here 2, and this one is 2. So 2 plus 2, 4. So now the number of atoms of the reactants is equal to the number of the atoms of the product. Now this is the balanced reaction. So always when you write the reaction, it should be a balanced reaction. Now let's see the definition of a balanced chemical equation. A balanced chemical equation is the simplified representation of a chemical reaction which describes the chemical composition, physical state of the reactants and the products, and the reaction condition. We saw all these, isn't it, using an example. Now here the chemical equation is nothing but the simple representation of a chemical reaction. In the sense, we are representing the chemical equation using the chemical formulas. And we also said that the physical state of the reactants and the product should be mentioned in the reaction, isn't it? Now when we were seeing the example of the methane combining with oxygen to give carbon dioxide and water, we said that the states, the phase of the reactants and the products are represented using the symbol, isn't it? And the reaction condition is also mentioned in the reaction. And we saw the example of the silver bromide, isn't it, that decomposes to silver and bromine in presence of light energy. So a balanced chemical reaction is one in which the chemical reaction is described using chemical composition, that is nothing but the chemical formula. Physical state of the reactants and the products are described, and the reaction condition of the reaction is also mentioned. Now let's see the types of chemical reaction. Now first is the classification based on the nature of the rearrangement of the atoms. The next one is the classification based on the direction of the reaction. Now first we'll see the classification based on the nature of the rearrangement of the atoms. So these are classified into, the first one is the combination reaction. Now this combination reaction is classified into three types. The first one is that element plus element gives the compound. The next is compound plus element gives compound, and here compound plus compound gives compound. So this is called as the combination reaction, and this is classified into three types. The next one is the decomposition reaction. Now in decomposition reaction there are further classification. The first one is the thermal decomposition reaction, electrolytic decomposition reaction, and photodecomposition reaction. And the next type is the single displacement reaction, and the next one is the double displacement reaction. This double displacement reaction is classified into precipitation reaction and neutralization reaction, and at the last combustion reaction. So this is about the classification based on the nature of rearrangement of the atoms. The next we'll see the classification based on the direction of the reaction. Now based on the direction of the reaction, it is classified into reversible reaction and irreversible reaction. Now we are going to discuss about each and every type of the chemical reaction. Now first classification is the combination reaction, isn't it? So this classification is under nature of the rearrangement of the atom, isn't it? Now combination reaction, as the name indicates, combine. What combines? Two or more reactants combine together to form the compound. So it is called as combination reactions. Two or more reactants combine together to form the compound. Now look into the example, children. The general example: A is an element and B is an element. This combines together to form the compound. So two or more elements combine together to form the compound. Now here you can see the example. For example, hydrogen molecule combines with the chlorine molecule to give hydrochloric acid, that is HCl. So H2 plus Cl2 gives 2HCl. So this is the combination reaction. Here two reactants combine together to form the compound, single compound. Now this combination reaction is also called as synthesis reaction or composition reaction. So these are the other names for the combination reaction. Now in combination reaction we said that it is further classified into three types, isn't it? Element plus element gives the compound, compound plus element gives the compound, and the last one is compound plus compound gives the compound, isn't it? Now let's discuss them one by one. Now the first type is element plus element gives a compound, isn't it? Now here the reacting species are element. Two elements combine together to form the compound. Now out of these two elements, one can be a metal, another can be a non-metal, or both the element can be a non-metal, right? So these are the possibilities. Now let's go to the first example of element plus element gives a compound. Here you have hydrogen combines with chlorine to form the hydrochloric acid, isn't it? Now here these two reacting species, that is the reactants, are non-metals. Both are non-metals giving a compound. Now the second example, sulfur combines with oxygen to form sulfur dioxide. Even in this case, the sulfur and the oxygen, that is the reacting species, are non-metals. That is, both are non-metals to give the compound. Now let's move into the third example. Now here sodium combines with chlorine to form sodium chloride. Now here sodium is a metal isn't it? And that is combining with a non-metal chlorine to form the compound. Out of these two elements, one can be a metal and the other can be non-metal, or both the element can be non-metal. Now the next type is compound plus element gives the compound. Here one compound combines with another element to form the compound. Now look into the example, children. Here PCl3 is a compound, isn't it? So it combines with the element Cl2 to form PCl5. Now the product is the compound. The other example is sulfur dioxide combines with oxygen to form sulfur trioxide. Now sulfur dioxide is a compound that combines with oxygen. It is an element. Now gives the product sulfur trioxide, which is in compound. So these two are the examples of compound plus element gives the compound. Now the next one, the last one, is the compound plus compound gives the compound. Now look into the example, children. Silicon dioxide, that is SiO2, combines with calcium oxide to form calcium silicate, that is CaSiO3. Now this is a compound, combines with the calcium oxide, again a compound, gives the compound calcium silicate CaSiO3. Right? Now the second example is calcium oxide combines with water to form calcium hydroxide. Now the compound combines with the compound to give the compound. All the combination reactions are exothermic reaction. Now why it is exothermic reaction? Since it is a combination reaction, the formation of a new bond takes place, isn't it? Now when there is a formation of a new bond, the energy is released, we said, isn't it? When we were discussing about the chemical reaction, we said that whenever the formation of new bond takes place, a huge amount of energy is released in the form of heat. So it is an exothermic reaction. So all the combination reactions are exothermic reactions because of the formation of new bond. A huge amount of heat energy is released. Next we'll move to decomposition reaction. Now in decomposition reaction, the single compound splits and gives simpler products, isn't it? Now here this reaction is opposite to that of the combination reaction, isn't it? Now in combination reaction, what happens? Two or more reactants combine to form single product, isn't it? Now here the single compound splits to form the simpler substance or the simpler products. Now look into the example, children. Here you have the compound AB, a compound on decomposition splits into A plus B. Now since it is a decomposition reaction, the bond breaks, isn't it? And for the breaking of bond, we said that the energy is required. It needs energy for the breaking of bonds, isn't it? Depending upon the nature of the energy that is used in the decomposition reaction, the decomposition reactions are classified into thermal decomposition, electrolytic decomposition, and photodecomposition reaction. So the first classification is thermal decomposition reaction. It is also called as thermolysis. Why it is called as thermolysis? Because the decomposition takes place by using the heat energy. Thermo means heat, isn't it? Thermal means heat energy. So the decomposition takes place by using the heat energy. So it is called as thermal decomposition reaction or thermolysis. Now let's see the example. Now look into the first example, children. Here you have a mercury dioxide, isn't it? Now this absorbs the heat energy and decomposes into mercury metal and oxygen is liberated. Now here this is a compound, isn't it? Now this compound decomposed to give elements. So these two are the elements, that is the product are the elements, isn't it? So this is called as compound element decomposition, right? So this particular example comes under compound to element decomposition. Now look into the second example, children. Here you have calcium carbonate. On absorbing heat energy, what happens? It decomposes to calcium oxide and carbon dioxide, isn't it? Now here this is a compound and the products that is formed is also compounds, isn't it? So the decomposition of the compound gives two compounds. So this comes under the classification compound to compound decomposition, right? So in both these two reactions, heat energy is observed for the decomposition reaction. So it is called as thermal decomposition reaction. Now when you talk about the decomposition reaction, since the breaking of the bond takes place, the energy is observed, isn't it? So this comes under endothermic reaction. So the decomposition reactions are endothermic reaction because heat energy is needed to break the bond, to decompose, isn't it? The next one is the electrolytic decomposition reaction. It is also called as electrolysis. Now why it is called as electrolysis? Because the decomposition takes place by using electrical energy. When electricity is passed through the aqueous solution, the decomposition of the reactants takes place and the product is formed. So it is called as electrolytic decomposition reaction. Now look into the example, children. Here you have the aqueous sodium chloride. When electricity is passed through the aqueous sodium chloride solution, it decomposes to metallic sodium and chlorine is liberated. Now this is the decomposition reaction. Here the compound decomposes to elements, isn't it? So these two are the elements, sodium and chlorine are the elements, isn't it? So this comes under the classification compound to element decomposition. So since electricity is used, the energy used is electricity, this reaction is called as electrolytic decomposition reactions or electrolysis. The next one is the photodecomposition reaction, which is also called as photolysis. Now why it is called as photolysis? The energy that is used is the light energy. Photo in the sense light, isn't it? We know about photosynthesis. Light energy is used, right? So here using the light energy, the decomposition of the reactants takes place, isn't it? Now let's see the example. Now here you have the silver bromide. Silver bromide, on observing the light energy, it decomposes to metallic silver and bromine gas is liberated. Now here the silver bromide will be yellow in color. On observing light energy, it decomposes to metallic silver, which will be gray in color. Now if you see this silver bromide, it is a compound, isn't it? Now on decomposition, it gives elements. The products, both the products are elements, isn't it? So it comes under the classification compound to element decomposition. It comes under the class compound to element decomposition. So here the decomposition takes place by observing the light energy. So it is called as photodecomposition reaction or photolysis. Next one is the single displacement reaction. Now in single displacement reaction, the reaction takes place between an element and a compound. And the product will be a compound and an element. Now here, look into this example, children. Here A is an element that combines with the compound BC. Now here what happens? Displacement in the sense one of the element in the compound is displaced or replaced by the element. And here you will get AC plus B. Now here what happens? B is replaced by A, isn't it? So instead of BC, you will get AC plus B, right? So here one of the element of the compound is displaced by the element and you get a compound and element. So this is called a single displacement reaction. Now let's see the example. Now here, when zinc is placed in the hydrochloric acid solution, now hydrogen will be liberated and the displacement takes place, isn't it? Now what is displaced? Hydrogen is displaced by zinc. So zinc displaces the hydrogen and zinc chloride is formed. Now let's see the second example. Here iron combines with copper sulfate and forms iron sulfate and copper. Now here iron displaces the copper. So iron displaces the copper and forms iron sulfate. So here the element of the compound displaces the element and the compound plus element is formed. So this is called as single displacement reaction. The reaction takes place between the element and the compound, and one of the element in the compound is displaced by the element. Now it is easy to predict so many reactions of this kind of different combination, isn't it children? The single displacement reaction. But will it occur in practice? Now let's see that. Now here you have two examples. One is the sodium chloride reacts with fluorine to form sodium fluoride plus chlorine. The other one is NaF reacts with the chlorine to form NaCl plus F. Now these are the two reactions. Now we'll see which one occurs, right? Now here the sodium chloride combines with fluorine, isn't it? So fluorine displaces the chlorine in this compound and NaF and chlorine is formed, isn't it? So fluorine displaces chlorine in this reaction. Now if you take this reaction, here NaF combines with chlorine to form NaCl and fluorine. Now here chlorine displaces the fluorine. Now the second reaction does not occur. It is not feasible. Now what do you mean by feasible? It do not occur in practical, right? Now why it does not occur in practice? Now because the chlorine displaces fluorine, isn't it, in this reaction? Now chlorine is less reactive and fluorine here is more reactive. So less reactive element will not displace more reactive element. Only a more reactive element displaces the less reactive element. And look into the first example here. The fluorine displaces chlorine, isn't it? Now fluorine being more reactive displaces chlorine, and this reaction is feasible in the sense it occurs. But the second reaction do not occur because the less reactive element will not displace the more reactive element. So this does not take place. So what decides the feasibility of the reaction? What decides or determines whether the reaction occurs or not? The activity of the element and the position, that is the relative position in the periodic table. So these are the two criteria which decides or determine the feasibility of the reaction, that is whether the reaction takes place or not, right? Now always we should remember that the more reactive elements displaces the less reactive elements. It do not occur the other way, that is the less reactive elements does not replace the more reactive elements. So always we have to remember that the more reactive elements displaces the less reactive elements. So in the displacement reaction, the feasibility of the reaction is determined by two key factors, isn't it children? Just now we saw the activity of the element and their relative position in the periodic table, and this leads to the activity series, and the activity series of some elements are given in your textbook. Now look into the screen children. Here you can see the activity series. Now activity series consists of the elements starting from potassium to platinum. Now here the elements that is placed at the bottom are least reactive and the elements that is placed at the top are most reactive. Now in between here you can see the hydrogen is placed, which is a non-metal, isn't it? So the elements below hydrogen are least reactive, and the elements that is placed at the top are most reactive. So more reactive elements are readily displaced by the less reactive elements in the aqueous solution, and that determines the feasibility of the reaction. Now let's see an example. Let us take two elements, one from the bottom of the series, the other from the top of the series. Let's see which metal displaces hydrogen gas from hydrochloric acid. Now let us take silver and zinc. Now where is silver present? It is present at the bottom, isn't it? So and it is least reactive. Now where is zinc present? It is present above hydrogen, isn't it? Now which metal displaces hydrogen from hydrochloric acid? Now here zinc displaces hydrogen from hydrochloric acid because zinc is more reactive compared to that of silver. So the more reactive elements readily displaces the less reactive elements from their aqueous solution. The next one is the double displacement reaction. Now in double displacement reaction, two compounds react. Now in single displacement reaction, we said that one element combines with the other compound to give compound plus element, isn't it? Now here two compounds combine in the double displacement reaction. Now here in the double displacement reaction, one ion of one of the compound is interchanged with the ion of the other compound. And here the interchange of the ion takes place in such a way that the identical charge ions get interchanged. Now what do you mean by identical charge ions? So we know that the cations, isn't it? Cations are the positive charge ions, isn't it? So cations are replaced by the cations and anions are replaced by the anions, or cations and cations get interchanged and anions get interchanged, isn't it? So that is identical charge ions get interchanged. Now this reaction, that is the double displacement reaction, is also called as the metathesis reaction, right? Now this is sometimes asked in the objective types of question, children. Now let's see the example. Now here these two are the compounds, isn't it? Now when these two compounds reacts, again the product will be in compound, isn't it? Now here the double displacement takes place. Now the ion of one compound gets interchanged with the ion of the other compound. Now here what gets interchanged? B is interchanged with D. So D takes the place of B. Now what will be the product? Now here it is AB reacts with CD, isn't it? Now the product will be AD plus CB, right? So these two are the products. One of the product can either be the precipitate or the water. So depending upon this, it is classified into precipitation reaction and neutralization reaction. Let's see them one by one. Next is the precipitation reaction. So this is one of the type of double displacement reaction we said, isn't it? Now here in aqueous solution, two compounds combine together or the displacement reaction takes place. Now in aqueous solution, when two compounds react, the product that is obtained can be one insoluble compound and the other will be an soluble compound. So you will have two compounds in the product side, isn't it? So in that, one will be an insoluble compound, the other will be the soluble compound. Now what happened to the insoluble compound? It gets precipitated, isn't it? So it will settle at the bottom of the test tube, isn't it? So since it settles at the bottom of the test tube, it is called as the precipitation reaction. So in the product, one of the compound will be insoluble, the other one will be soluble. So it gets precipitated, so it is called as precipitation reaction. Now let's see the example. Now here it is lead nitrate combines with potassium iodide to give lead iodide and potassium nitrate. Now these two are the compounds in the aqueous solution, combines, undergo double displacement reaction to give lead iodide and potassium nitrate, right? Now here in the product, one of the product is insoluble, so that is lead to iodide is insoluble, so it precipitates at the bottom of the test tube. So since the precipitation of the lead iodide takes place, this reaction is called as precipitation reaction, and the compound that is precipitated is indicated by a downward arrow mark, which indicates that it settles at the bottom of the test tube, right? It precipitates. So this is about precipitation reaction. The next one is the neutralization reaction. So this is one of the type of double displacement reaction, isn't it? Now in your lower classes you would have learned the reaction between an acid and base, isn't it? An acid and base neutralize with one another to form salt and water. So this is the general reaction for the neutralization reaction, isn't it? So this is one of the type of double displacement reaction. Now let's see the example. Now here you can see that the hydrochloric acid combines with the sodium hydroxide. Now this is the acid here, hydrochloric acid, and this is the base, that is sodium hydroxide. These two neutralizes with one another to form salt, that is sodium chloride with water, right? Now here we said that one of the product is water here, isn't it? So it is called as neutralization reaction. Now in the neutralization reaction, the sodium displaces hydrogen from hydrochloric acid, forming sodium chloride, and this is the neutral soluble salt, isn't it? So this is one of the example of neutralization reaction. Now let's see the other example. Now here nitric acid combines with ammonium hydroxide, and the product that is obtained is ammonium nitrate and water. So this is also a neutralization reaction, that is neutralization between a base, that is ammonium hydroxide, and the acid, that is nitric acid, takes place, and it forms ammonium nitrate and water. So these two are the examples of neutralization reaction, and this is another type of double displacement reaction. Now let's see the difference between combination reaction and decomposition reaction. Now in combination reaction, one or more reactants combine to form a single product, isn't it? Combination synthesis reaction, isn't it? But in decomposition reaction, the single reactant decomposes, splits into one or more product, isn't it? Now in combination reaction, the energy is released. Why? Because the new bond is formed, isn't it? Now for the formation of new bond, we said that always energy is released, isn't it? Now we also said that the combination reactions are exothermic reaction because the formation of new bond takes place and a huge amount of energy is released in the form of heat energy. So it is exothermic reaction. Now on the other hand, if you compare the decomposition reaction, energy is observed because here the splitting of the reactant into the product, isn't it? Now here energy is observed and it decomposes, that is breaking of the bond takes place, and most of the decomposition reactions are endothermic reaction because heat energy is observed and it is called as endothermic reaction. Now if you see the third difference, elements and the compounds may be the reactant in the combination reaction. That is, elements may combine to give the compound or compounds may combine to give the product. Now here in decomposition reaction, single compound is decomposed to give more than one product, one or more product, you can say. So this is the difference between combination reaction and decomposition reaction. So far in this session, we have learned about what is chemical reaction, balancing chemical reactions, classification based on the rearrangement of the atoms. Now, in that, we have learned about the combination reaction, decomposition reaction, how the decomposition reaction is classified into thermal decomposition reaction, electrolytic decomposition reaction, and photodecomposition reaction. And we have also seen about the single displacement reaction. Double displacement reaction is further classified into precipitation reaction and neutralization reaction. We'll continue with this lesson in the next session, children. And now your homework for today is that you should write the thermal decomposition reaction, electrolytic decomposition reaction, and photodecomposition reaction with the examples in your class book. And you should also learn these types of decomposition reaction with the reactions, with the balanced reaction, right? And submit the classwork in the school office on Friday. See you in the next session, children. Thank you.